doing? The recent changes of base table will be applied to the materialized view. Recent changes are stored in materialized view log file. If this log file is not there, how can it apply recent changes? If this materialized view log file is not there, refresh will be failed. This is a problem. Okay. So to create this materialized view must be there. So database administrator creates materialized view like this. Create materialized view log on. Okay. On which schema and which table that he specify here. C # batch 2 PM. In that one EMP table is there. That EMP table. And this table must have primary key. Table must have primary key. Then only we can create. Table must have primary key. Table must have primary key. Then only we can create materialized view log file. Materialized view log file. So to create the materialized view log file, the table must have primary key. Otherwise we cannot create. So database administrator creates one materialized view log file like this. Okay. As of now in the EMP table, no primary key is there. We have one EMP table. See, observe here, select star from EMP. This is the EMP table. This EMP table is not having any primary key. So I want to add primary key here. So to add primary key, alter table. Observe here, just a minute. In fast refresh, we write like this. So this is fast refresh. Sorry, this is complete refresh. Okay, for fast refresh, instead of writing complete here, what we are writing? Fast refresh. Okay, but if you create like this, now this will be failed. Okay, for example, observe here, MV9 we are creating. This is which refresh type? Complete refresh. Is it creating or not? Just observe, it is creating. So whenever we refresh this materialized view, it uses which way? Complete way. So complete refresh will be performed. So complete refresh means what? Deletes complete data, execute select query again. The result will be filled in the MV9. Okay. I want to create fast refresh now. I want to create fast refresh. For the fast refresh, we are writing like this. Refresh fast we are writing. Now this materialized view creation will be failed because materialized view log file is not there. Okay. So materialized view log file is not there. Sorry, MV10. MV10 I am giving. Name is already exists. It is telling. Okay. So actually, just a minute. Okay. So observe here. See, here we are using refresh type. Which refresh type? Fast. What is the error it is giving? Just observe here. Okay. Batch 2 PM schema. In this schema, in the EMP, does not have a materialized view log. If materialized view log file is not there, you cannot create this fast refresh. Because for fast refresh, this materialized view log file is compulsory to maintain the recent changes. If this materialized view log file is not there, where you maintain the recent changes? Okay. So if anyone is deleted this materialized view log file, our fast refresh will be failed because of this materialized view log file only. It is applying the changes to the materialized view. So materialized view log file we have to create. So to create the materialized view log file, primary key is compulsory. For example, here I am trying to create the materialized view log file. Observe, generally database administrator creates it. Now I'm creating as the user only. So create materialized view log. Create materialized view log on which table? EMP table. So is it creating the is it creating the materialized view log file? Observe. See here, table EMP does not contain a primary key constraint. So with this, we can understand that to create the materialized view log file, the table must have primary key. Otherwise, we cannot create. Okay. So because of this reason, I am adding the primary key now. Alter table. Table name is EMP. Add constraint. Add constraint. So constraint name I'm giving as CC1. So add constraint. Constraint name I'm giving as CC1. Primary key. Okay, primary key we are adding for employee number. So primary key we are adding for employee number. So I'm giving 4 C's 1 here. So primary key we are adding to the employee number. So what it is telling? Table altered. Now previously when we were creating materialized view log file, it was giving error. Now again we are trying to create materialized view log file on EMP table. Is it creating the materialized view log file or not? Yes. So whatever the changes we apply on the base table EMP now. So this is the materialized view. We want to create by using fast refresh. So when we create this materialized view, now because of materialized view log file is available, materialized view will be created. Okay. So after that, when we are performing when we are performing refresh on this materialized view, it uses fast refresh. Means it takes the help of materialized view log file. But if anyone is deleting our materialized view log file, our materialized view will not be refreshed. So if materialized view log file is not available, if materialized view log file is not available, then fast refresh will be failed. This is a problem. So all the recent changes of base table will be recorded in materialized view log file. Only these changes will be applied to the materialized view in fast refresh. But this materialized view log file is not there. If materialized view log file is not there, then fast refresh will be failed. Then what is the solution here? So the solution is we have to use force refresh. So force refresh type. Third way is force. So in this type, in force refresh, what happens here? In force refresh, so it is not in our hand. It is completely, this force refresh is in the hand of Oracle. Oracle gives first priority to the fast refresh. Oracle try to do here. Now you know two types of refreshes. One is complete refresh. Another one is fast refresh. In the complete refresh and fast refresh, which one is the faster? Fast refresh is the faster. Why? Because only recent changes it is applying. Okay, wherever in a complete refresh, what is happening? Complete action it is performing again. So again it is executing select query. Again that select query result it is filling. Okay, so two refresh ways two refresh types complete refresh, fast refresh. So Oracle gives first priority for fast refresh. So Oracle gives first priority for fast refresh. Oracle try to perform fast refresh only. So Oracle gives first priority for fast refresh. So in the fast refresh, one problem is there. What is that problem? If materialized view log file is not there, this fast refresh will be failed. It cannot perform the fast refresh. So that's why what happens here, Oracle gives first priority for fast refresh. In case of fast refresh, if materialized view log file is not there, it is failed. So Oracle gives first priority for fast refresh if materialized view log file is not there. If materialized view log file is not there, then Oracle performs complete refresh. Oracle performs complete refresh. Oracle performs complete refresh. That's it. So, see, in case of complete refresh, what is happening? Again, select query executing, that select query result, it is filling in the materialized view. In case of fast refresh, what is happening? Only recent changes it is applying. But in force refresh, what is happening? First priority, it is giving for the fast refresh. So Oracle trying to apply recent changes to the materialized view. But if materialized view log file is not there, in case of fast refresh, that will be failed. But in case of force refresh, what happens here? Then Oracle performs complete refresh. So here, definitely refresh will be succeeded here. In case of fast refresh, if materialized view log file is not there, that will be failed. But in case of force refresh, if materialized view log file is not there, then it performs complete refresh. So refresh will be succeeded definitely here. So that's why we use this force refresh. That's it. These are the 3 refresh ways. So finally, I'm giving the conclusion. There are 3 refresh types are there. Okay. First one is what? Complete. Second one is what? Fast. Third one is what? Force. Okay. So for force refresh, we write like this. Just a minute. For example, here instead of writing fast here, what we write here? Force. Force we write. So there are 3 refresh types out there. First one is complete. Second one is fast. Third one is force. In complete refresh, what it will do? Truncates complete data. Truncates complete data from materialized view. After this, what it is doing? Again executes select query. Result will be filled in. Okay, result will be filled in materialized view. In case of fast refresh, what is happening? Only recent changes in materialized view log file. Recent changes in materialized view log file will be applied to base table. Not base table, materialized view. The recent changes of materialized view log file will be applied to the materialized view. Base table changes only you are applying to the materialized view. Okay, but here the problem is if materialized view log file is not there, it will be failed. It will be failed. So whereas in force refresh, what happens here? Oracle gives first priority for. So Oracle performs fast refresh. If materialized view log file not available, then it performs, Oracle performs complete refresh. That's it. So in fast refresh, there is a chance of failing refresh, but in force view, definitely our materialized view will be refreshed. Refresh will not be failed here. Okay, in fast refresh may be failed here. Refresh may be failed. Okay, whereas here refresh will not be failed. In force refresh will not be filled. So refresh will not be filled. That's it. This is about refresh types. Now you know 3 refresh types: complete, fast, and force. Last point is the materialized view. Last point is enable query rewrite class. So what is this enable query rewrite? Why we use this class? See here, listen carefully. You already know the purpose of materialized view. Okay, what is the purpose of materialized view? To improve the performance, we are using this materialized view. If we use view concept, so every time it has to calculate, so performance will be degraded. So that's why we are calculating it and we are storing it physically in some other materialized view. Okay, so materialized view improves the performance. To improve the performance only, we are creating this materialized view. Now, we are creating one materialized view here. Try to understand. See, we are creating one materialized view. Create materialized view. Materialized view name I am giving as MV12. As select department number, comma, sum of salary from EMP group by department number. So like this, we are creating one materialized view. So why we are creating this materialized view? We want to improve the performance here. If any user wants department-wise sum of salary, so we are giving permission on this materialized view, so he can access the data. Okay. So this MV12 is holding department-wise sum of salary. It is holding department-wise sum of salary like this. 10th department sum of salary, 20th department sum of salary, like this it is holding the data. Department-wise sum of salary it is holding. So we created this materialized view to improve the performance. If anyone wants department-wise sum of salary, he has to access from this materialized view. But there is one user is there, is the Java developer. There is one user is there, is the Java developer. He wants to display, listen, in his Java application, he want to get department-wise sum of salary. In his Java application, Java developer wants department-wise sum of salary. So to get department-wise sum of salary, he is writing this is select query. Okay. So if this select query is submitted to the Oracle, what happens? Every time it calculates department-wise sum of salary. If this select query is submitted to the Oracle, so Java developer from the front-end Java application is submitting this query. So if this query is submitted to the Oracle, first time he is submitting, it calculates department-wise sum of salary. Second time he is submitting, again it calculates department-wise sum of salary. Okay, so like this, every time it is calculating department-wise sum of salary here. Assume that this Java developer frequently wants to work with department-wise sum of salary. So frequently he is submitting this query. Oracle is performing this action. Frequently it is performing the calculation. Automatically performance will be degraded. So actually to improve the performance, we created one materialized view MV12 here. But this Java developer has no information about that materialized view. He is submitting normal query. So now this materialized view creation will be wasted here. To improve the performance, you created this materialized view. But Java developer is submitting normal query. It is every time it is calculating, Oracle is calculating department wise sum of salary. So our materialized view creation is wasted here. Why it is wasted? Because Java developer has no information about this materialized view. That's why he is submitting the query. If he has information about the materialized view, what he writes here? Simply he writes select star from MV12. If Java developer has materialized view information, he writes like this. Java developer has no information about the materialized view, he is submitting normal query. So if he retrieves from materialized view, performance will be improved. But he is submitting normal query. So every time department wise sum of salary will be calculated, performance will be degraded. So to avoid this problem, when we are creating this materialized view, what we do is, so in this case, what is happening here? Java developer has no information about materialized view. So he is submitting normal query. So every time department wise sum of salary, sum of salaries will be calculated and performance will be degraded. Every time department wise sum of salaries will be calculated and performance will be degraded. So to solve this problem, we use enable query rewrite. If materialized view is created using enable query rewrite class, even if user submits normal query, data will be retrieved from materialized view. So understand the problem and understand the solution here. For calculating department wise sum of salary to improve the performance, we created this MV12. But this information is not there to the Java developer. If Java developer is having information, he writes select star from MV12, but he has no information. He is submitting normal query here. If he is submitting normal query, okay, what happens here? Every time department wise sum of salaries will be calculated and performance will be degraded. To avoid this problem, we are creating materialized view by using enable query rewrite. If materialized view is created using enable query rewrite, even if user submits normal query, data will be retrieved from materialized view. Every time it will not perform calculation. So automatically performance will be improved. So what we write here, to create this materialized view, instead of writing like this, what we are writing now, we are writing like this. Create materialized view name. Here we write enable query rewrite. Enable query rewrite class we are writing. So if we write like this, even if user is submitting normal query, data will be retrieved from materialized view. So you already know how to see the execution plan. To see the execution plan, what we write? Set auto trace on explain. So set auto trace on explain we are writing. So with this you can understand, is it retrieving from the table or is it retrieving from the materialized view? To understand that we are using it. Now observe carefully here. See, I'm showing it practically. Observe. Set auto trace on explain. To see the execution plan, I'm writing this command. On EMP table, I want to create one materialized view here. So create materialized view. Materialized view name I'm giving as MV12. As select department number, comma, sum of salary from EMP group by. department number. Like this we are writing. So materialized view is created. So now materialized view is created. We are retrieving data from select star from MV12. We are writing. So from where it is retrieving the data, now see here, it is displaying materialized view. This materialized view is holding department wise sum of salary. The result it is displaying. So it is retrieving data from the materialized view. Observe here, materialized view full access. In the execution plan, it is showing that it is retrieving data from the materialized view. From which materialized view? MV12. For example, I am submitting normal query here. I am submitting normal query. Now from where it is retrieving? From table, from EMP table. If you submit normal query, from where it is retrieving? From the table. If you are retrieving data through the materialized view, from the materialized view it is retrieving. Now what is my requirement? Even if I submit this normal query, that should retrieve from materialized view only. Because if it is retrieving from the table, every time it will calculate. Again I am submitting the normal query. It is calculating department-wise sum of salary. Again I am submitting the normal query. Again it is calculating department-wise sum of salary. So automatically performance will be degraded here. So to improve the performance only we created materialized view. But that materialized view is not useful when we submit the normal query. Even if user submits normal query that has to retrieve from the materialized view, in such type of situations, we create the materialized view like this. Enable query rewrite, we write. For example, I am giving this materialized view name as MV13. Now observe carefully here. Materialized view MV13 created. In this we are using which class? Enable query rewrite class we are using. Now observe carefully. I am retrieving data from the materialized view. It retrieves from materialized view only. Observe. Now I am submitting the normal query. I am submitting the normal query. Then also it retrieves data from the materialized view. Observe. Even if we are submitting the normal query here, for normal query also it is retrieving data from the materialized view only. So again, is it performing department-wise sum of salary here? No. Okay. Whenever we are submitting this normal query, okay, it is retrieving data from the materialized view because of enable query rewrite. Okay, see here. Every time is it calculating? No. MV13 has pre-computer result. That pre-computer result it is giving. Babu, please don't talk. Okay, even if subject, please don't talk. After completion of subject, you can discuss. Okay, so this is the concept of enable query rewrite. So here I explained one case. Our frequent operation is calculating department-wise sum of salary. So to improve the performance, we created one materialized view, but this information is not there for the Java developer. So now Java developer is submitting this normal query. So if normal query is submitted to the Oracle, every time it calculates department-wise sum of salary, performance will be degraded. To improve the performance, when we are creating the materialized view, at that time we are creating materialized view by using enable query rewrite like this. If materialized view is created using enable query rewrite, even if we submit the normal query, it retrieves data from, even if we submit normal query like this, it retrieves data from materialized view only. So again, it is not calculating. So automatically performance will be improved. Is this point clear? Next. Just like all tables information stored in user tables, all views information stored in user views, okay, all indexes information stored in user indexes, all sequences information stored in user sequences, like that all materialized views information stored in user underscore views. So it maintains all materialized views information. So all materialized views information stored in the user underscore MViews. Okay. So select, if you want to see the structure of this user underscore MViews, describe user underscore MViews we write, because we don't know which columns are there. So we are seeing I'm setting auto trace as off here. So set auto trace off. Describe user underscore MViews. See here, MView name. MView name we want. So we write MView underscore name from user underscore MViews. So select MView underscore name from user underscore MViews. So it is displaying all materialized views information. See here. Till now we created these materialized views. Okay. Next. Dropping materialized view. To drop the materialized view, we write drop materialized view. Materialized view name we give. So drop materialized view. Materialized view name we give. So drop materialized view name MV1 we are giving. So materialized view is dropped. So this is a way of dropping materialized view. So this is about materialized view. Materialized view concept is over. Next topic is synonyms. This is a small topic. Okay, within 15-20 minutes, I cover this topic. After that, I stop the session. Listen. So with this, SQL will be over. Last database object, synonym. What is synonym? See here. See, listen. See here. You already know about column alias and table alias. For example, we are writing like this. Select employee number, EN. Okay. E-name, EMPN, or EMP name. So like this. From EMP, E. Like this we are writing. Now you tell me what is EN here? EN is the column alias. What is EMP name here? EMP name is also column alias. What is E here? Table alias. For example, in first query, I am giving alias name as EN here. For the next query, can I use that alias name here? Okay. In the first query, for the employee number, I am giving alias name as EN. For the E name, I am giving alias name as EMP name. Okay. Now, can I use these alias names in the next query? No. It gives error. Because column alias is limited to that query only. Column alias or table alias, that scope is limited to that query only. For example, here instead of writing EMP, can we write E here? This alias name can we use here? No. So this table alias, this column alias and table alias, these are temporary. Within that query only we can use. In another query we cannot use. Okay. So sometimes table names may be lengthy. Like this. Employee, for our convenience purpose, we created short. We have given short name EMP. In the real time, table name may be like this. Employee salary details. Try to understand. So, when the user wants to frequently with this table, every time what he has to write? He has to write lengthy table name. Employee salary details. Employee salary details like this. So every time he has to use lengthy name. For example, for this employee salary details table, for example, assume that C hash hash batch 2 p.m. is the owner. There is another user is there, Ravi user is there. Now Ravi wants to access this employee salary details table of batch 2 p.m. Now Ravi uses table name as C hash hash batch 2 p.m. dot employee salary details. So is it not becoming more lengthy? Observe here. Actually table name is lengthy. So we are using schema name dot table name. It is becoming more lengthy. So just to make these lengthy names short, we are using the concept, synonym concept. This table alias is temporary. Synonym is permanent. That's it. So what is the purpose of synonym? See here. Synonym is a database object. The synonym is a database object. Why we are using it? It is used to give alias name to the database object. It is used to give alias name to database objects. So to the database objects, if you want to give another name, alias name means another name. So it is used to give alias name to database objects. This synonym is permanent. Synonym is permanent. Whereas table alias is temporary. Table alias is temporary. So table alias name can be used within that query only. Means table alias scope is limited to that query only. So table alias scope is limited to that query only. In another query we cannot use. But whereas the synonym is permanent, in any query you can use this name. For example, here EMPE, this E name we can use within this query only. We cannot use in another one. Here we cannot use. Because these alias names scope is, this column alias or table alias names scope is limited to that query only. Okay, leave about this column alias. For table alias, if you want to give permanent name, we use the concept synonym. So synonym is permanent, whereas table alias is temporary. Table alias scope is limited to that query only. But whereas synonym, anywhere you can use. So just it is used to give alias name to database objects. Alias name means alternative name. So to give alternative name to database objects, we are using this synonym concept. What is the syntax here? Observe. Syntax is create synonym name. Create synonym name for which database object you want to give that alias name, the database object name we have to give. This syntax we have to follow. Very, very simple. So just we are giving another name to the existing database object. So observe here, my requirement is, see, select star from EMP I am writing. Select star from EMP. Okay. So I want to make this table name short. So I want to give alias name as E here. I am writing like this. Select star from E. What it is giving? Tabular view does not exist. But I want to use E name for retrieving this EMP table. So for the EMP table, we want to give alias name as E. That is our requirement. So what we have to write now? Create synonym. What is the synonym name? E. Okay, synonym name E for which database object? EMP. So for EMP database object, we are giving alias name as E. Create synonym E for EMP. So create synonym E for EMP we are writing. Okay, insufficient privileges it is giving. So to get permission, we have to log in as database administrator. So database administrator has to give the permission for creating the pseudonym. Grant create pseudonym to grant create synonym. To whom he has to give the permission? To C hash hash batch 2pm. So who has to give this permission? DBA. So login as DBA. So DBA writes this command. Observe here, I'm logging as database administrator. Connect system. Password is Naresh IT. We are giving permission for creating the synonym. Create synonym. To whom? To the batch 2pm user. So now batch 2pm user can create the synonym now. Now login as batch 2pm, C hash hash batch 2pm. Okay, now we want to create the synonym. Observe here, create synonym E for EMP. Okay, observe what it is telling. Synonym is created. So now, instead of using EMP name, I can use E. Observe, whenever our requirement is retrieving data from EMP table, we have no need to write EMP. Simply we can write E. Observe, it is displaying EMP table data. Previously, when we were writing select star from E, it was giving error. Tabular view does not exist. But now after creating this synonym E, this E is the alias name for EMP table. Select star from E means it is retrieving data from EMP table. For the EMP table, another name is E. I want to delete a record. For example, I want to delete this 1012 record. This 1012 record I want to delete. So delete from table name I am giving as E. So delete from E where employee number equals to 1012. So here we are using synonym. Observe. So is it performing delete operation? See? Yes. Okay. For example, I want to update. Okay. All employees. I want to increase 1000 rupees salary to all employees. Update E. Update E. Set salary equals to salary plus 1000. Now it increases 1000 rupees salary to all employees. Observe. So select star from E. Now previously 1012 record was there. Now 1012 record deleted and to all employees 1000 rupees salary increased. So like this, we can use the synonym. This synonym is permanent or not? Observe. Yes, synonym is permanent. Every time we are using. But whereas table alias is temporary, within that query only we can use. Next. What are the advantages we are getting here? By using synonym, what are the advantages we are getting? One advantage is advantages. First advantage is, see, so it makes table name short. It makes table name short. And another advantage is it avoids of writing schema. It avoids of writing schema name every time. For example, see here, C hash hash batch 2pm is the owner of EMP table. He is giving permission on this table. He is giving permission on this EMP table to another user, Ravi. Okay. So now Ravi wants to access this batch 2pm users EMP table. What he writes now, select star from C hash hash batch 2pm dot EMP. Is it not becoming lengthy? Observe here. So every time he has to write schema name dot table name. In our example, table name is short here. Tomorrow table name may be lengthy like employee salary details. Here we have to write C hash hash batch 2pm dot employee salary details. It becomes more lengthy. To make it short, what this Ravi is doing, Ravi is creating one synonym here. Ravi is creating one synonym. So Ravi creating one synonym, create synonym E for for C hash hash batch 2 p.m. dot emp. So from next time onwards, he has no need to write this schema name dot table name. Just he can use the synonym select star from E. So now this E is another name of C hash hash batch 2 p.m. dot emp. So for C hash hash batch 2 p.m. dot emp, we are giving alias name as E. So E is equivalent to C hash hash batch 2 p.m. dot emp. So it is making this much lengthy name short. To make lengthy name short, we are using the concept, synonym concept. That's it. So now I'm showing it, observe. So here, current user is batch 2 p.m. user. So there is another user, Ravi user is there. He wants to give permission on this EMP table to the Ravi. So he's writing like this, grant all on EMP to C hash hash batch, C hash hash Ravi. To the Ravi he is giving permission. So grant succeeded. Now Ravi wants to access this table. So connect C hash hash Ravi. Narrating. Sorry, maybe password is Ravi. Okay. So let me check, is there any table with the name E? No. Okay. Now observe. Select star from C hash hash batch 2 p.m. Okay. So is there any EMP table here? No EMP table is there. He wants to access, Ravi wants to access batch 2 p.m. CMP table. So he's writing C hash hash batch 2 p.m. dot emp. So who is the owner of this EMP table? Batch 2 p.m. He has given permission to the Ravi. Now Ravi is able to access, but every time Ravi has to use this schema name dot table name, it is becoming lengthy. So he wants to make it short. So that's why he is creating one synonym here. So create synonym. Maybe he has no permission for creating synonym. Let me check. E for C hash hash batch 2 p.m. dot emp. Okay. So he has no permission for creating the synonym. Database administrator has to give this permission. So connect system. Naresh IT. He is giving permission like this. Grant create synonym. Grant create synonym to C hash hash Ravi. So now Ravi can create the synonym C hash hash Ravi. So now who is the current user? Ravi is the current user. Now Ravi wants to create the synonym. What he is writing? Create synonym. Synonym name is E for C hash hash batch 2 p.m. dot emp. So every time writing C hash hash batch 2 p.m. dot emp is becoming lengthy for Ravi. So that's why he wants to make this as short. He is creating one synonym E. From next time onwards, he has no need to use this much lengthy name. He can use short name E. Observe here, select star from E. See here. Now it is displaying the data from batch 2 p.m. users EMP table. So, and it is also provides security. It also provides the security. If we create the synonym and on that synonym, if database administrator is giving the permission, this user cannot know who is the owner of that table. Okay. What is the original table name? He cannot know. So security also will be there with this synonym. So in the future, whenever Ravi wants to work with batch 2 PM's EMP table, he uses E name. If he wants to update the salary to all employees, he updates like this. Update E set salary equals to salary plus 1000. Yes. See, synonym is working. Okay. Now these changes will be applied to the batch 2 PM users EMP table. So next, this is the purpose of synonym. Okay. Only one purpose is there. We are making lengthy table name short. That is the main purpose of the synonym. So we are making lengthy table name short. If we are giving permission to the other users, he has to write schema name also. It avoids of writing schema name. These two advantages we are getting with the synonym. In the synonyms, two types are there. Types of synonyms. How many types are there? Two types are there. What are those? First one is private synonym and second one is public synonym. So private synonym and public synonym. So there are two types of synonyms. One is private synonym and another one is public synonym. What is this private synonym? Just now we created one synonym, that is private synonym only. This private synonym is created by the user. If user is creating synonym, he creates the private synonym. Okay, what is public synonym? This public synonym is it is created by the database administrator. So database administrator creates public synonym. Normal user creates private synonym. So for multiple users, if we want to create the synonym, we create the public synonym. So for multiple users, if we want to create the synonym, then we create public synonym. Okay, if one user wants to create it for his personal purpose, he creates a private synonym. So this private synonym is created by the user. Okay, if user wants to make table name short for his personal purpose, for his personal usage, he can create private synonym. So private synonym means the user who is creating that private synonym, only that user can use it. Others cannot use it. But whereas public synonym means it is created for multiple users. So multiple users can use same name. So syntax to create the public synonym. Try to understand. For example, there is a case. First I'm writing the syntax to create the public synonym. For public synonym, see the syntax. Create public synonym name for database object name. So this syntax we have to follow. So observe here if this public keyword is not there, that is private synonym. If public keyword is there, that is public synonym. Who creates this public synonym? Database administrator. Who creates private synonym? User. So why database administrator is creating this public synonym? See, there is a case. For example, there is EMP table is there. So who is the owner of this EMP table? For example, batch 2 PM is the owner. There are some users are there. C ##. Batch 7 AM user is there. And C ##. Batch 11 AM user is there. And C ##. Batch 6 PM user is there. These users wants to access this EMP table. Okay. Shubham, if you don't have interest, you can go, you can leave. You can attend another class, you can leave. No need to send the messages here. You can leave, Shubham. See, batch 2 p.m. user. This batch 2 p.m. user is the owner of this EMP table. Batch 7 a.m. user, batch 11 a.m. user, batch 6 p.m. user wants to access this EMP table. So now what this batch 2 p.m. user is doing? He is giving permission, grant all on EMP to C hash hash batch 7 a.m. comma C hash hash batch 11 a.m. comma C hash hash batch 6 p.m. Like this, he is giving permission to 3 users. Now 3 users can access this EMP table now. But the C hash hash batch 7 a.m. if he wants to access the table, what he has to write? Select star from C hash hash batch 2 p.m. dot EMP he has to write. Okay. Same batch 11 a.m. user also he has to write select star from C hash hash batch 2 p.m. dot EMP. Batch 6 p.m. also he has to write C hash hash batch 2 p.m. dot EMP. So what this 7 a.m. user is thinking is every time writing like this is becoming lengthy. He wants to create one synonym. So he is creating one synonym here. Create synonym E for C hash hash batch 2 p.m. dot EMP. So batch 7 a.m. user frequently want to work with this EMP table of batch 2 p.m. So every time writing schema name and table name, it is becoming lengthy. To make it short, he is creating one synonym for his convenience purpose. Like that, batch 11 a.m. user is creating his own synonym for his convenience purpose. Like that, batch 6 p.m. user is creating his own synonym for his convenience purpose. So like this, if every user is creating synonym for the same table, number of synonyms will be increased. So instead of creating these many, every user is creating his own synonym. Observe here. So it increases number of synonyms here. Instead of creating these many synonyms, so instead of creating, okay, individual synonyms by the user. So instead of creating individual synonyms, okay, database administrator creates a public synonym. Database administrator creates a public synonym. On this, DBA gives permission to other users. That's it. Instead of creating individual synonyms, DBA creates a public synonym. On this public synonym, DBA gives permission to other users. On this public synonym, DBA gives permission to other users. So it decreases number of synonyms here. It decreases number of synonyms. Number of synonyms will be decreased. So if we follow this way, every user has to create his own synonym. Instead of that, database administrator creates one public synonym. Create public synonym EE for which table? C hash hash. Database administrator can use any schemas, any table. So on batch 2 p.m. users EMP table, he is creating public synonym EE. So now grant all on EE to C hash hash batch 7 a.m. comma C hash hash batch 6 p.m. comma C hash hash batch 11 a.m. So to the multiple users, he is giving permission on this synonym. Now next time onwards, if batch 7 a.m. user wants to access batch 2 p.m. users EMP table, he will not use schema name. Just he uses the public synonym E. Okay. So if we follow this way, how many synonyms we are creating? One synonym, one public synonym. That's it. If we follow this way, Every user is creating his own synonym. 3 users are creating 3 synonyms here. To decrease this number of synonyms, we are using this public synonym. Just observe here. I am creating one public synonym here. So connect C hash hash. Okay, batch. Sorry, system. Database administrator. Connect system. Narration. Observe. I want to create one public synonym. So create public synonym. Okay, if any synonym is there with the name EE, I'm dropping that one. Drop public synonym. Drop public synonym EE. Okay. So I'm creating one new public synonym here. So create public synonym. This public synonym name is EE for C hash hash batch 2 PM dot EMP. So for batch 2 PM users EMP table, we are creating one synonym. That synonym name is what? EE. So on this EE, we are giving permission, grant all on EE to, for example, we are giving permission to Ravi. So now Ravi has no need to use this schema name dot table name. Now Ravi uses C hash hash Ravi. Just simply Ravi uses the public synonym. Observe here. Select star from EA. Okay. So Ravi is using the public synonym EE. This is the way of using public synonym. So all synonyms information stored in user synonyms. So to see the all, it maintains all synonyms information. All synonyms information will be maintained here. Okay, so we don't know the structure of this one. So we are writing describe user underscore synonyms. Okay, observe here. I'm logging as our batch schema C hash hash batch 2 PM / Naresh IT. Okay, describe user synonyms. Okay, so this is the structure. So select synonym name. Select synonym name from user synonyms. Means it will display all synonyms list created by us. Till now we created only one synonym. That synonym name is what? E. So to see the synonyms list, we are writing select synonym name from user synonyms. Dropping private synonym. To drop the private synonym, we write drop synonym name. Dropping public synonym. To drop the public synonym, we write drop public synonym. Drop public synonym name. So this is the way of dropping public synonym. This is the way of dropping private synonym. So this is about synonyms. Synonyms topic is over. This is about SQL. So successfully we finished SQL topic. Okay. So tomorrow I start another language, that is PLSQL. To communicate with Oracle database, we use 2 languages. One is SQL, another one is PLSQL. So now you know clearly about SQL. So SQL language is over. So tomorrow I start another language, PLSQL. Okay. Thank you everyone. See you tomorrow. It takes 1 month time. 1 month time for PLSQL. So it takes 1 month time for PLSQL. Yes, Imran. Any doubt? Imran, are you there? Any doubt? You can ask. You can type in the chat box. Okay, Hari Krishna, you please contact to the admin. I don't know. Okay, you please contact to the admin.